Hi, good afternoon. I'm Mark Paulson, and today we're going to be talking about weight and balance. And weight and balance is one of those things that's really important to calculate each time you fly. Basically, flying outside of the center of gravity limitations, flying above the maximum gross weight, below the minimum gross weight, these are all things that can lead to a really hazardous situation. We're going to start talking about weight in and of itself, some definitions, talk about balance and what that means as far as the aircraft is concerned. We're talking about some different methods to compute the weight and balance, and then actually talk about some of those hazards that mentioned. All right, so first, talk about some of our different kinds of weight. And the first weight I want to talk about is basic empty weight. So basic empty weight is the weight of the aircraft with all equipment installed. So you got aircraft at no fuel, but also full operating fluids. So your engine oil, transmission fluid, hydraulic fluid, all that kind of stuff. So you got zero fuel and full fluids. Okay, and the next one I want to talk about is your useful load. And the useful load is anything that's left over after the basic empty weight. So you take your maximum gross weight, which we're going to talk about in a little bit, and subtract your basic empty weight, and that's all the weight that you have to work with. So your useful load would include yourself as a pilot, passengers, baggage, anything that you're carrying with you on your person. So the useful load is accounts for fuel, pilot / passenger, and also baggage. Right? And the maximum gross weight, that is the weight that cannot be exceeded by the manufacturer's recommendations, essentially. So max gross weight is the maximum operating weight of the aircraft at any given time. So basically just the highest operating weight. And then you also have payload, which is another definition of weight, and that would basically be your useful load minus fuel. So the payload is any sort of baggage and your weight and any sort of other cargo that you want to carry with you at the time. So we talked about minimum gross weight. I'll just mention as well that maximum gross weight, there is a minimum gross weight for most aircraft, and that has to do with its ability to auto-rotate. It needs that weight to keep to descend at an appropriate rate. And so the R-22, it's about 920 pounds, which is pretty hard to get down to with even a solo pilot and the basic empty weight of most of the R-22s around. So now we're going to talk about balance. And balance, there's basically two parts to balance. There's a longitudinal component and a lateral component. So we'll start off with our longitudinal. Draw my excellent aircraft here. So the longitudinal component has to do with the center of gravity about the vertical axis here, but also what we call a reference datum. So what is that here? And that datum can be basically anywhere the manufacturer wants to put it. So for the R-22, we can look in the POH, it's 100 inches forward of the main rotor mast centerline. Some aircraft will just use the rotor mast centerline, and other manufacturers might use the nose of the aircraft as a reference point. But the goal of the datum line being forward of the aircraft is so that everything, all longitudinal balance calculations are positive. So that's the key. And the datum line is really just a reference point to for all the equipment installed in the aircraft. It's just a and so the longitudinal, and then we have also the lateral. There's another awesome aircraft here. And it splits the aircraft in half horizontally. And here you do have a negative and a positive component. So on the left side of the aircraft, we have a negative. And on the right side is positive. So that's your basic balance points here. So we've got your datum line, which is the reference point for measuring distance, and you've got your longitudinal and your lateral. So some different methods of computation. First you have just the calculation. So the calculation method, you need three things. First, you need weight. The second thing is your arm. The arm is the distance from that reference datum. And then you have moment. And moment is just the product of your weight times your arm. So with any two of these three things, we can figure out the other. So our basic weight balance calculation is weight times arm equals moment, which we can just so that's your basic calculation method. And then once you have total moment for all of your whole aircraft as it is, full fuel, everything you want to fly with, and then you just divide that by your total weight, and you can get your center of gravity, which is the arm of the aircraft at that point. So we can do a practice calculation here with just a simple number. So if we have our weight, 50 pounds, our arm, distance from datum, let's just say 10 inches. So your total moment will be 500. Pretty simple, pretty straightforward. I mean, we'll do a couple of practice things at the end and make sure that we're nice and comfortable with it. I think you've been doing several as you've been flying, so it's looking good. So some of the hazards associated with flying either outside of the CG envelope or above or below the gross weights. We mentioned before the minimum gross weight, the auto rotation hazard. You might not be able to keep those RPMs up with the lowered weight. Flying above max gross weight will do a lot of things to your aircraft. First of all, you'll be using more power than you should have to in a given situation if you're above gross weight. It's going to increase your ground roll. Just put undue stress on the aircraft. It's just something that's easy to avoid and should be avoided at all times. Flying outside of the CG envelope, if you are If your center of gravity is well aft of the CG limit, then it looks something like this. And even when you take off, so here's your your mass center point. And it puts the tail so low that you've got a possibility of tail strikes coming in on landing, even taking off. You have to apply an excessive amount of forward cyclic. It'll limit your forward airspeed because you're going to have to use so much forward cyclic to maintain a level attitude. And if you have too much forward CG, make something like this. Same thing. Basically, your controls are limited. You'll be using so much aft cyclic to maintain a level attitude that you might have not have enough left to slow your approach, or in case of an auto rotation, you'll be hard pressed to get enough aft cyclic to produce a good flare and build those RPMs. So basically, what we want to do is stay well within those CG limits. Alright, so we talked about weight and balance, some basic definitions, how to compute it. I will mention that another way to calculate weight and balance is with a graph. Pretty uncommon. The most common way is the combination method, which uses basic calculations along with a graph to give a visual representation of the CG. Alright, well, thanks for tuning in, and see you next time.